people worry about artificial intelligence getting a hold of nuclear weapons. And no, like what makes human dangerous is not that we were handed out nuclear weapons by somebody else, that some foolish person built nuclear weapons and left them. We made nuclear weapons for ourselves. The thing that can do that is dangerous, not because it then ends up with nukes, but because it's smarter than you and can plan the route through reality that ends with you dead, whether it was by nuclear fire or some other fire. Artificial general intelligence is the notion of the kind of mind that can do things that it wasn't built for, wasn't trained on. A bee builds hives, a beaver builds dams. A human looks at them and imagines a honeycomb-shaped dam, giant dam structure. And like, what makes it sensible to look at a human and say, like, those are significantly more general intelligences than chimpanzees is the way that we handle this very wide range of tasks that we didn't explicitly evolve to do. We didn't explicitly evolve to build rockets and go to the moon. It's just that the skills for chipping flint hand axes and outwitting other humans generalize sufficiently well. We could understand all these areas. We could understand the high vacuum. We could understand the solar light above the vacuum. We could understand the rocket equation. We could understand the rocket fuels. All these things that our ancestors did not know, we understand without having been built to understand them. We generalize. We aren't truly general. We're terrible at, for example, writing code. Our code has bugs in it, which is, not necessarily a way that a mind needs to work. It could just like do some of those processes without making errors and generating proofs along the way that it would work. But we can still do it at all. We're not like fully general, but we're more general than chimpanzees. And the thing to be scared of is the thing that is more general than us, that has the spark, it's not magic. It's not that we are conjuring new brain structures from the ether. It's just that the brain structures we were built with to solve the problems of our ancestral environment generalize sufficiently well. GPT-4 is able to do a bunch of stuff that it wasn't obviously trained to do in any particular way by predicting text on the internet, like drawing a picture of a unicorn when it has never seen a unicorn, was never trained on images. You just like ask it to write a program that draws a picture of a unicorn. It doesn't do too terribly at that. It doesn't do great, but it's never seen anything at all. So that's starting a bit to generalize a bit further than we would expect cats to generalize, wolves to generalize, non-humans to generalize. That's why the paper where they recount this sort of thing is called Sparks of General Intelligence.
Hi, I'm Logan Bartlett, the host of this podcast. I just wanted to take a quick second to tell you that we have a bunch of killer guests coming on over the course of the next few weeks. And so if you're enjoying these conversations with both entrepreneurs and investors, please do subscribe to our channel so you don't miss out. Why won't we be able to monitor and figure out what's going on inside this system, and if it's revealing something but actually doing something else? Why won't we be able to have any checks and balances to figure out, hey, if it's using compute resource beyond what we expect it to do, or whatever, that it's deviating from the goal as we understand it?
Well, I mean, these are sort of like a bunch of different questions. So first of all, I frequently use the phrase these days, giant inscrutable matrices of floating point numbers, though when I wrote the Time letter, people were like, the editor correctly said, like, our readers do not necessarily know what floating point numbers are. So I said, okay, giant inscrutable arrays of fractional numbers. Yeah.
Did that stay, or do they strike that?
That stayed.
Got it.
So giant inscrutable matrices of floating point numbers and giant inscrutable vectors of floating point numbers moving through it. We don't know what's in there. We don't know what's in the matrices.
And why don't we know what's in there?
Well, because we make these things in the first place by, doing very basic calculus to this giant mess of numbers to see, well, in what direction would the probability assigned to the correct word go up if we tweaked all those numbers. And we tweak them by going down this direction, and the gradients are inscrutable, and the directions are inscrutable. It's just like never starts out scrutable. It's just, we understand the program that makes the AI, but we do not write the AI, we do not understand the AI, and it's just very hard in practice to look at these giant messes of floating point numbers and figure out what do they mean.